We are now covering Learning Target 6.6. I can define and explain the concept of latent heat. So if you know anything about specific heat, then latent heat shouldn't be that much more difficult. So the definition for latent heat is the amount of heat required for a substance to change phase. So it's a little bit like specific heat, except at this time it is talking about the heat required for a change of phase. So that's changing from like a solid to a liquid. The reason why is because let's just consider water. So when water is in solid form, it is ice. It is ice because the energy from the water has been removed and bonds start to form to create a solid structure. So you can imagine little bonds in between the molecules that are forming. Okay? If I were to add heat to this, it would begin to increase in temperature like specific heat says it will. But then eventually it'll reach a point at which it starts to, you guys know it, melt. It'll start to melt and you'll see a pool of water until eventually it turns completely into like a cup of water. Okay? The question is, how much Q does it take to do that? Well, the answer is latent heat. Okay, depending on the substance, it's going to take a different amount of heat to go from a solid to a liquid, or to change phase. Okay? The amount of heat that is required is called latent heat. Alright? Why do you need to add heat to change phase? Because if we go back and think about those bonds that are inside a solid, we have to break those bonds in order to get it to become a liquid. And that is why you need to add heat. And it doesn't change the temperature of the ice, it just changes the phase of the ice into liquid. And then as soon as it's all liquid again, like it is over here, then it'll begin to increase in temperature if you keep adding heat. But that is no longer latent heat. Latent heat just has to do with the change in phase. That's the important part. Alright, so for the individual example, I want you to consider this question. Water boils at 373 degrees Kelvin. Does it take more energy to get from 373 to 374 than it does to get from 300 to 301 K? Why or why not? So pause the video, try your best, and then see if your answer matches mine. Okay, so the answer to this question is it does take more energy to get from 373 to 374 than just from here to here. Okay, and that's because when water, so H2O, goes from 373 to 374, it is going from ice to water. Okay? Which means that is a phase change. And a phase change takes more energy to raise it 1 degree or 1 Kelvin of increase in temperature, as well as a phase change. So when you were talking about going from 300 to 301 K, that is just 1 Kelvin increase in temperature. Okay? When we're going from 373 to 374, that is also 1 Kelvin change in temperature, so it's equal there. However, between those two temperatures, there is a phase change, which adds more energy, which we call latent heat.